Welcome to the Power Up Podcast. I'm your host, Trevor Scullion. Join me for some powerful conversations with members of the Substation Design Solutions Industry Consortium, the SDSIC. I'll chat with members about the consortium, innovations, how they're implementing different technologies, even some of the projects they're working on to address the growing needs of our power grid. Joining me today is Michael Bruce, co-founder and implementation consultant at 3D Transition Services. Michael and his team are long-standing members of the SDSIC, and the work they do, turning LiDAR scans into 3D models and model-based design into augmented reality, they've been pushing the limits of 3D technology now for almost 2 decades. Great. Thanks for joining me today, Michael.
Thanks, Trevor.
Yeah, so as you know, this podcast was an idea to kind of introduce a lot of the different members, right? So the SDSIC now is 1,768 members this morning. So the phenomenal growth over the years, and really wanted to get to know different members and give folks a chance just to kind of have something to listen to and easily go through and get to know folks. So why don't we start a little bit about your background?
Okay. I got to thinking about that for the last couple of days since I found out we were going to do this.
Yeah.
It was like 40 something years ago. So I actually started out in a machine shop. I was not very wealthy when I was young. My mom, single parent. We didn't have a lot of money. Back then you had to pay to go to school. So I didn't really have a chance to start. I started college, but it didn't really last very long. And I actually started working in the drilling industry, working for a downhole tool manufacturer at the time, Drillco. And I went to their machine shop and learned how to run lathes and mills and big, huge. These are machines that make drill collars, which are thousands of pounds heavy for drilling wells, oil and gas wells. And so I started there, really, and went through the company. I worked in their different management programs. I was partly in sales for them, which was kind of interesting. And a young person like that, I used to spend time in the North Sea early on in my career. And after that, stayed in the same business, but then went to another company, one of the huge tool companies that did work above the rig floor, got into really more of a engineering role, even though I wasn't technically an engineer. I helped to design top side pipe handling systems, and a lot of it was retrofit work. So we'd take an existing drill ship or a semi-submersible, and we would design this hydraulic system that was remotely operated from consoles. The drilling industry traditionally in handling pipe is always done with people on the derrick, people on the floor, lots of danger. But in the North Sea, when you have a floating, or in the Beaufort Sea, even in Canada, when you have a floating drilling vessel, it's hard to do those kinds of things. So the company developed these remote operating systems. They weren't really remote. They were more joystick, like a crane. Okay. It was automated and it was modular. So very early on in my career, I started working in modular type businesses. And then I got some experience with some interesting companies. I worked for a brief time before the oil industry went out in '85 with a robot application company, and was introduced to the Mikado robotic system, automation system at McDonnell Douglas that at the time was run by a VAX 11780. I think it was 780. Nice. And which was a room next door to the little computer screen we had with the robot in it, showing how it was operating. It was actually quite phenomenal. It was one of the best things. I guess it really kind of drove me to looking at automation in my life. That was my experience with it. And it was unique. It was very rare. McDonnell Douglas automation, at the time was sort of, bridging these gaps for where the aircraft industry went eventually. More sophisticated software like Inventor SolidWorks and CATIA. But anyway, it was great for me. The only problem is that, the oil business really, it went under in 85, and I was one of a lot of people who moved away from the Houston area. I had a friend who worked for a company called Hilti, and he moved to Detroit. Told me to come up there, so there was lots of work. And so I went to work for some steel fabricators, and even for a short time had my own business. My mom passed in 1991, I think it was, moved back to Houston, and things had changed a lot. There wasn't the oil business the way it used to be. Construction was kind of so-so, and I didn't really know what I wanted to do. So for a while, just to make some money, I decided to sell cars. And
wow.
that I got introduced to a person at one of the BMW stores there, and they asked if I wanted to work there, and I said, yeah, I guess.
It's got to be easier than selling to guys in the North Sea.
Exactly. And so I made so much money doing that that it really was hard to, even though I kept wanting to go back into the construction business and everything that goes along with it, oil and gas and everything, the money was just too good. I couldn't pass it up. So I ended up spending 17 years selling BMWs, which is interesting. But on my desk in my office, I had Oil and Gas Magazine, ENR. So I was like the guy who was really just doing this work, selling cars, but really didn't love selling cars as much as technology and building and construction and all that. So anyway.
Wow, that's awesome.
So we moved to Louisiana. We were actually in Florida. I was selling BMWs for the most part. I moved from Houston to Florida, and it was great. I loved it for 10 years, but we moved to Louisiana, and then that's when I worked for the local dealer. But it's a very small dealership that sold Mercedes and BMW. Unless you knew something about, if you knew every doctor and every lawyer, then you had a customer. If you didn't, you had to go find them. So it wasn't the easiest thing to do.
Yeah,
and,
for sure.
One of my wife's cousins worked at Distran Package Substations and said, hey, we're hiring people, and you have a construction background. Maybe you'd like to work over there. So I went over there, and they hired me to do steel detailing, which I actually a lot. And I didn't know a lot about AutoCAD, though. That was the big challenge, because when I did steel detailing, it was with a pencil and electric eraser and all that. So I had a challenge at, I guess it was 46 or so. And, but I picked up AutoCAD pretty well. And that's really how I got into the high voltage substation business. And I've really been doing it ever since. This was in like 2008 or so is when I went to work for them. So it's been quite a while I've been in the high voltage business.
Wow, and that's when I first met you, was Distran, and you were.
Yes.
I still remember it actually from all the customers we visit over the years. Right, I went in there. You showed me an animation, and I think at the time it was Joey Baker that was in Distran doing the package stations and everything. And Joey said, "You got to come see this guy." And we went in, and you were in the back room. You showed an animation of the whole station, kind of the package station being put together on a 3D animation, and it was phenomenal. And that's that'd be like 2013, maybe 12, I don't know.
2013, something like that. Well, what happened was we did all of our we were steel detailing was done in AutoCAD, right? Arcs, lines, and circles. And we always had issues. It took you twice as long to check the drawing as it took you to make it. And Joey was always coming in saying, I don't want to count bolts. We have thousands of bolts, and
right.
Packager, we supply everything, including bolts, hardware, switches, steel, the whole works. So he says, I'm tired of counting bolts. That's what I always hear. That's the thing that reminds me of Joey. But anyway, so one day we got 2009, I think it was, that AutoCAD came out with 3D. And one of our customers, Con Ed, happened to do some very complex switch stands. And what was complex about it was the way they ran grounding on their structures. So what they did is they took I think it's 1.5 inch wide aluminum bar, and they would bolt it to the structures, and it would be bolted to itself, and it goes around corners, up and down and all around.
Oy.
Try to do something in 2D like that. You had to do a side view, a top view, and then another side view. And then you had to figure out, okay, it's going around this corner. I mean, for this little aluminum bar, we would spend hours trying to figure out how to put it on a drawing so that we build them and prefabricate them in the shop. So when 2009 came out, I started learning about extrusions and subtracting. And so that's when we started realizing how important 3D would be to us, especially in the steel fabrication area. And one day I did that structure in 3D, and Joey came in and looked at it, and he just said, man, he said, we got to find a better way to do this, because it was time consuming. It was not easy to do. And so there was a meeting with our local rep, Vaughn Kloss. I don't know if you know Vaughn or not.
Oh yeah, I do.
He worked, I think he still works at Distran, and a great guy. He had he was a reseller in Lafayette at the time, and he was our reseller for our products. And so he came up and gave a presentation on Inventor and Advanced Steel, which I think at the time was Graytech.
Yep.
And I think everybody's jaws, dropped to the floor when they saw all this technology. And so they started, I guess, talked about it for a while, and they said, this is something we need to do. So they came to us and said, hey, we need some volunteers, because we want to start using this Inventor. We thought the decision between Graytech and Inventor was that we wanted to eventually be able to take the equipment and combine it with the structural element. And the Graytech system really was just steel, right? It was like Tekla, or what is now Advanced Steel. So it didn't really have the easy ability to work together and having equipment, steel, and other things all in one model. So that's where we said, okay, we'll bite the bullet and we'll do the Inventor thing. And when they asked for volunteers, nobody would raise their hand.
Of course.
I mean, after they saw it, everybody goes, whoa, this is quite different. And so I said, okay, I'll volunteer, but, I'm not going to guarantee anything here. And at the time, I think I had maybe 1.5 years of AutoCAD under my belt. So
wow.
It was one of those things, but it was probably the easier because I wasn't ingrained so much in the way AutoCAD worked. So that it was more easy for me to sort of look at how it operated and make and adapt to it. But the biggest problem was, and this is, I think I gave a presentation at AU in 2015 about the leap from 2D to 3D. And I think it's still, you can still get the slides. It wasn't videoed or anything, but the slides are on there. And some of the slides show, how you're really going from something that you're easily used to every day, and you don't even really think about it when you hit a key, to something that you have to think about it from the beginning of what you're going to do. There's involved, all that kind of stuff. So it's much more complex, but now it's easy for me. Versus when it was then. So it was a mind you had to change. And the biggest problem we didn't have a lot of people in our department. And so what happened was we decided we wanted to do Inventor. We'd go see Vaughn, go to our classes in Lafayette. I think we had like a 3-day or 4-day course. And then we had to come back to the office. And we came back to the office, all this work was sitting in front of us waiting for us to do it. So we didn't learn enough to go ahead and do it in Inventor. So we had to change hats and go back to AutoCAD, and we spent time on AutoCAD for like 2 or 3 days or 2 or 3 weeks, and then we said, okay, we got to get back to Inventor. Well, we had pretty much forgot, not that it was bad or anything, but we had just forgot a lot of the things that we had learned when we went to learn about Inventor. And of course, Vaughn didn't know anything about our business. So when we went down there to learn about Inventor, we were basically making parts. We weren't really doing assemblies.
Right.
And in station design, you're basically doing assemblies from parts. Even some people may make parts, not enough of them do, in my opinion. But anyway, it's more assembly operation, right? So it was hard. So it took us about, my partner was a guy named Brant Cook. He still works at Distran, great kid, or he's not a kid anymore, he's got a family, but at the time, and he just had graduated from school. He knew Inventor, he knew nothing about Substation. I knew Substation, nothing about Inventor, so it was a great partnership. And it took us about a year to put together our first substation, and it was phenomenal when we did. Everybody was pretty happy, and that's kind of how it got started at that company, and we moved it from there. So
wow, yeah, that's such a common theme too. You know, we hear that a lot where folks go for training, and then you get back to the office, and you know, guess what? The work has to get out the door, right? You got 100 work orders, 100 field corrections, and you just go right back into doing the work on, you know, MicroStation, AutoCAD, you know, whatever it was before, and you forget all about Inventor and even the AutoCAD electrical side, right? They'll go back and, you know, you end up doing the quick work and just editing it in AutoCAD or MicroStation. So yeah, it's a good lesson for the folks listening that are just getting started, right? You really got to be dedicated to the effort after the training. Don't go back to the old way.
Yes, and that really comes to management. You know, people always ask me, you know, what made it successful for you? And it was really one word, well, two words, Joey Baker, because Joey didn't want to count bolts. He wanted to count. And so it was Joey, because he was the president of the company, and all the people that ran Distran at the time, everybody had to be on board. And you know, don't get me wrong, it wasn't one big happy family, because there were some people that weren't really happy about it, because when you go to a tool like this, it changes not only your department, but it changes every department in the company, because its outputs are quite different from what they're used to getting. And information that they're getting now is a lot more than what they're used to getting. So from a marketing standpoint, accounting, shipping, I mean, you name it, it affects every aspect of the company when you change your CAD system or your software in it. And people in the engineering department, well, we don't think about that. We don't think about what those knock-on effects are. So it caused some issues. And the people, you know, in the company who were used to banging the keyboard all day long on AutoCAD. One guy I worked with, love him to death. He went through keyboards. I mean, he went crazy in AutoCAD, but when it came to using Inventor and having to click a mouse that clicked a box that, you know, didn't really have a keyboard element, it was so difficult for him, he couldn't really do it. And so, you know, there's good parts and bad parts about it, and you just have to be ready for them when you're making this transition, because, you know, from management or from personnel, everybody's involved in some form or fashion. It's important to make sure they understand what's going on, because most people don't know what's going on when these things happen. And without them and having some input, at least letting them know what's happening, what to expect, it makes a big difference.
Yeah, and I'm really glad you brought that up. And yeah, big shout out to Joey Baker. I've been trying to get him on too, but he's been busy lately, so I'll have to nail him down in a couple of weeks. But yeah, it's so important to have management on your side, because I can't tell you how many conversations we've had with design teams where the first thing they want to talk about is making the drawings from Inventor look the way they did in the old system, whatever it was, MicroStation, 2D AutoCAD, you know, Felix CAD, whatever. It didn't matter, but they want it to look like that. And I said, that's a terrible way to start the conversation, because they're not going to look the same.
Well, and you ask so what question, why are they wanting to do that? Well, the question is, or the answer is, that they don't really want people who receive those documents to realize that they're different.
Yes.
And that they're getting essentially the same thing that they've been looking at for a long time, so that it's not as big a transition for them. But then when you start putting 3D details and 3D assemblies on a drawing and then sending those to the shop or the field, then it gets their attention and they're like, wow, this is awesome. Can we have some more of this? So initially you want, and of course the people that you're dealing with usually are utilities. There's such a big difference the way utilities use Inventor and Substation Design Suite and people who build the products and fabricate them and manufacture them and ship them to the job site and have to install them. That difference in the two, Just-Trans uses the Inventor differently than Nashville Electric or whoever,
right?
Because they're the architect. The utility is the architect. If you think about it this way, if you think about Revit, for example, of course, maybe people on the broadcast don't know about Revit, but architects use Revit because it's a design tool for them to help them to easily design a building or house or whatever. But it really isn't beneficial to the people who are going to actually cut the lumber and nail the wood.
Right.
So that's why Inventor is so great, because Inventor can do that, right? It's just not used that way traditionally. And I always said, what really should happen in this transition to 3D and the utility industry is the utilities need to detail or design the substation using the generic structures and everything. And back then we didn't have a lot of content, right?
Yeah.
And so we had to design a lot of our content, but it had to be pretty accurate because we're talking about electricity. So we need to know about things. It's very, very important. So our switches had to be pretty close to what they actually are to design them properly. So anyway, I said they should just build the model and then send it to the manufacturers and let the manufacturers take it and then turn it into shapes. So that was always a big problem there. And we always ended up getting, AutoCAD drawings and then building models from them. And they still do it that way today. I think for the most part, I haven't been there in 5 years, but, that's one of the things that is a little bit of a hill to climb. And so people really do have to look at what their use is of the software and then figure out how they're going to make it becomes a product or something that's shipped to their facility for their use.
Yeah, that's a really great point with Revit, because you can tell just with the Autodesk side, the amount of effort they're putting into the correlation between Revit and Inventor, right? The integration between the two of them, being able to share files, and even in the architectural space, they'll use, they suggest that we use Inventor for things like the heating and ventilation and fans, and then they have great ways to publish it to BIM objects and all this cool stuff in Revit, right? So,
right.
Yeah, they're kind of taking your methodology. Maybe they saw your AU presentation years ago.
Well, fortunately, there's interoperability now with Revit. So, and for a really long time, people didn't know this, but if you need a circular staircase or you needed some kind of special equipment or something, people would reach out to somebody who had Inventor and they would design it and then send the model to them, but they would do it usually through like an STL file or something, IGES file, some generic file format, and then they would be able to import it. But today there's interoperability between the two, so it's less difficult to do. But it's interesting because we work in the AEC community as well, and we do unusual things with it. But they're realizing that it's really the best tool to use because you can build anything with Inventor, right? You can build a 47, a BMW, or a house. I know Autodesk doesn't want to hear that. Revit is their biggest selling, software. I'm sure Andrew is like cringing probably if he hears this broadcast, but it's one of those things that they just have the best tool around them. And it's really in Europe, people are realizing that CATIA and SolidWorks at Dassault Systems is becoming the way you probably want to do AEC. So that is happening. I think the same thing at Bentley, So the software manufacturers are realizing that you need a cradle to grave solution for building anything. It doesn't really matter what it is. It's just, it just happened to happen that way because of some discussions that people thought Revit would be the answer. And really, it's a great tool, honestly, for the AEC community. It's gotten better, lots of plugins for it. It's just not a great manufacturing tool. So that's I guess that's the big rub about Revit right now. And so people in the modular home business, the building business that we do, they're looking for a better solution that doesn't require, just a one-shot solution, basically like Inventor, that can do everything for them. They can send the files, the CAD files to a robot or to a 3D machine to print concrete houses. That's kind of what we've been talking to people about. They want to know, well, how does this BIM model you gave us allow us to print this 3D house? And we said, well, it's the same thing when we put it on the 3D printer. It's an STL file, basically. It may be a little different, but that's what's happening in additive manufacturing. And then with, you could take this conversation into Fusion and CAM and everything else, which we don't do in our industry right now. But that's really the solution is thinking about what you want to make and then having the ability to make it. So.
Yeah, that's awesome. Hey, I was going to ask you about the SDSIC, but I'm going to leave that till later on because there's a great conversation just around the CAD side and transitioning to 3D. So I want to ask you about, and I've been dying to ask you about your tagline, 3D transition services. I loved your tagline, moving into a virtual world of design and fabrication, which we're just touching on. Yeah. So this was 2017, you started 3D transition services, yeah?
Right. What happened was I wanted to retire. And I always thought, I wanted to be a consultant. And even Joey will tell you this, I was always saying, hey, listen, we need to go out and help our customers and, bring Inventor to them and that kind of thing, because it's going to be helpful to them, helpful to us. And so we spent a lot of time really educating the utilities. And the great thing about Distran is Distran did work for everybody. So
right.
Really, one of the things we had to adapt to was the utility standards, right? So AP's got their standards and Con Ed's got theirs and Southern's got theirs and everybody's got their own standard, right?
Yeah.
And a lot of times they're quite different. So we had to adapt to that at Distran, but we got to see all the different things and different ways people build substations and utilities build them. So it was an awesome place to be. And we had the opportunity to talk to different utilities. And I think over time, they started really realizing that. In fact, very early on, we talked to power engineers about what we were doing. And they were looking at us like, wow, this is the greatest thing since sliced bread. And look at power engineers.
They took your advice.
I think I was in that meeting with them, but anyway, it was great. And so people were starting to see, the benefits of 3D. And when you talk about the data management aspect of it and the information and the intelligence and everything that goes into Inventor, it just became, really understood that this is the way to go. So I think that's why it's been embraced by some of these companies, Burns and McDonnell, Duke Energy, the utilities that really use it, they see the value in it. And that's why they embrace it so much, but it's not an easy path. That is the rub.
It's been interesting. It's been interesting that the charter changes that we made in the SDSIC this year, thanks to Audrey and Mark, they went through and it really invited the engineering firms and services providers to join as co-chairs and kind of open that up. And as you just said, it's such a good perspective because they have to work with everybody. So when they talk about workflows and, even working with Vault and everything, document management, they have to do it with everyone. So they brought a terrific perspective. So folks like yourself, being able to come in and say, well, hold on, you can't do that workflow. That's specific to, AEP or Southern. We need to look at a broader, set of tools or something. It's been absolutely great for that.
Yeah. Yeah, and really most of the standards happen to be, I don't want to get off track here, but most of the standards have to be just things like the way we make our steel or the way our hardware is or the kind of switches we use. I mean, it's nothing really different. It's just really more of a content related thing. And so you build the content, hey, you're building AEP substations or whoever. So it really is a good way to if you have that opportunity and see other people's ideas and things like that, that makes you a much better company. But what I decided I wanted to do is I liked, Joey said, listen, we got to build substations, and Distran's known for their prefabricated designs for prefabricated bus and prefabricated jumpers at first. And then we started getting into substations, and then it's really turned into a big thing now because of Inventor, honestly. I mean, if we didn't have Inventor, we really couldn't have done what we ended up doing. And I enjoyed doing the work there, but I felt like I wanted to be more of a teacher. I wanted to break out and do consulting and help people go from AutoCAD to Inventor. So I retired in 2017, started my little business, thinking, okay, I'll get maybe one customer here or there. I ended up getting other people other than utilities wanting, us with transitioning from AutoCAD. So it kind of started there, and then a company called Valmont Utility, who's a member of the consortium, that really, they were making steel all this time, and they wanted to really get more into substation work, and they had customers asking them to do it. And so they called me up and say, hey, can you help us out trying to figure this out, what we can do and what we can't do. And so, I helped them and consulted for them for a few years. And actually it's supposed to be just 1 year, but it ended up being almost 5. Wow. But what happened really was that, they had been using Inventor since 2006.
Okay.
They were just really modeling everything, just the steel, and then they were just moving it into AutoCAD, or using the models to verify their AutoCAD, sort of a checking tool, honestly. So they weren't really using it, and really wanted to do substation building. So that's how we helped them. And they really couldn't do the work, so I hired some people, and we decided that we would help them, do some of their projects. I think we ended up doing like 20 or 30 substations. Wow. So it was a lot, very interesting. But big companies and big utilities are very hard to turn. It's like an ocean liner. They have procedures, and they have systems and people, and they have people that say, hey, we don't do it like this. We do it like this. So turning that ocean liner is really challenging, and it can be frustrating too. But you just keep plugging away, and you kind of hold their hand and show them the pitfalls, and make sure they don't fall off the edge of the bridge that they're trying to go across. So that's really, and honestly, that's the rewarding part, is seeing people embrace the technology, and then taking advantage of it and it benefiting them. So that's what we ended up doing. And then during the same course, I decided I love the AEC community. I always want to be an architect for some odd reason. Okay. But builder, I was a fabricator. So that's kind of what we decided to do for AEC.
Oh, wow. And you're doing, you do a lot of scanning, and you go from scan to models and all that kind of cool stuff too, right?
Yes. The scanning started actually, trying to think now, I want to say it was about 2013 or so. We had been given some scans by utility, and they wanted us to help them renovate a substation. And I don't know, Chris Ducote. Chris was my boss at the time, and Chris was busy. He was doing all kinds of stuff. He was in charge of our department, the substation group we were in. And he said, listen, would you look at this and see if you can figure out how we can take this scan and put it in Inventor? I said, you're asking me that, Chris? I said, you're the smartest one in this company, and you're asking me. So he said, listen, I just don't have the time. I said, okay, no problem. Let me see what I can do. So anyway, it was like, I don't know, 2 to 3 weeks trying to figure this out. And so we finally figured out how to import a scan into Inventor.
Mm.
And once we did, it opened up a huge world of possibilities that we didn't even really think of.
Mm-hmm.
So it helped us take these substations that they had. We were able to use the scans. We had to be in and out of the substation in 8 hours. They were 8 hours outage windows. Had to prefabricate everything, bring the module, take out, demo what was in. They were changing out some breakers and demo the old oil breakers that weighed 2,500 pounds a piece or whatever they were. And then bring in the modules that we'd done, prefabricated bus, prefabricated jumpers. I mean, wow. It had to fit, and you had 8 hours to do it. And we did wow. Substations for them. And that's when it became apparent to me that 3D scanning was going to become a big player. And so now today it still is. Our company does a lot of that now. And we do retrofits. I mean, we do things like boathouses that were destroyed by a hurricane. And
oh, wow.
Pilings are still there, but maybe some aren't straight anymore. But the can tell you all that. We can prefabricate the docks, the boathouse, whatever we need.
Wow.
We in the boats to make sure they fit in the boathouse. So when they pull them in, they can raise them up and the sky bridge isn't going to hit the top of the roof. That in Inventor. We do aerial flood analysis where we scan the whole facility of an office building or whatever. And then we use a work plane to go through it to show what happens when the water levels are high or low or whatever. So there are wow. tons of applications for 3D scanning. And we even, we bought scanners. So that's I guess when you decide to make that kind of investment decision, you pretty much have to use the technology. And so today it's the same thing. The best thing you can do is scan a substation because most substations are old. They have no drawings.
Right.
Have been probably remodeled many, many times.
Mm-hmm.
You go to do something in a substation, it's energized. Usually the easiest thing to do is scan that station, and then you'll know where everything's at, where the conduit's coming out of the ground, all the things are very important. What size bolts you have. I mean, the technology now is amazing. So we feel like, that's the best approach to take, and then, make a BIM model or an Inventor model of that. It doesn't have to be the whole station, but just what you need, to where you're going to do the work, and you're going to do an add-on or something. Then later on, if you don't have the substation built, you can have your people come in and fill in the parts of the station that you didn't do the work in. But it's a great way to work now.
No, that's awesome, and you're so right. I mean, I find I'm absolutely fascinated lately by the point clouds and just the way, how far the technology has come to be able to deal with these massive point clouds. I mean, 5 years ago, it would choke every machine we put them in. Yep. Now so I've been doing a bunch of machine learning and being able to subsample the stations, going down in point sizes and things to get them a little bit smaller and manageable for CAD. But I just think, I remember seeing that presentation from Distran when your team put together that sub. And I won't say the name of the utility, but you had the scan. I didn't realize then you were using the scan, and you were, you pre-assembled it in the plant. You had it all lined up, and then you disassembled and brought it on site and swapped them all out. And I remember the hours, like it was unbelievable the short time you did that in. And I remember leaving. I was with David Milks at the time from Autodesk, and we left that presentation and we went, "Wow, like why isn't everyone not doing this?"
Right. Well, at the time, it was pretty expensive.
Yeah. Right.
And it was a lot of money to do. Now that cost is nothing. And you can almost do some things with your phone. So
that's true. I remember the scanners were what, 100 and remember the Faro or Leica's scanners back then were what, 180 or 160 or something.
Mm-hmm. Yeah. Most good scanners, terrestrial scanners today are in the $40,000-$50,000 range, but there's things you can do with an iPhone or an iPad. So one of the things that's happening now, like if we need content for something, generally I'd rather just scan it and then build it from there. It's a lot easier. You can measure model. depending on what tool you want to use, and get a really good a model that can be used in AutoCAD or Inventor. And that's the beauty of it. You can bring a point cloud into AutoCAD. You can bring it into Navisworks if you need to share it.
Yeah.
And people can get a free version of Navisworks. So it's got a lot of capabilities now. And that's what I think is kind of lacking a lot when people are trying to redo something. So architects are looking at it, a little harder. It's harder for me to get their attention on a smaller scale. Smaller architects, they see the benefit, but they feel like it's too much work for them. But when you go to the larger architectural firms, they're using it.
Mm-hmm.
I mean, they have their own group that does that. And when you place that with photogrammetry and drones, it basically changes the way a lot of companies do business today. And don't have it, you really need to start using it or try to learn how to use it, because it's just as important as something like Inventor in terms of data and collection and being able to use that data easily without having to pull a tape, in a substation. That's the dangerous thing in the world. I use fiberglass, but still, you can't measure, while that thing's energized, and nobody's going to shut it down so you can take measurements. So it's,
Right. Well, and that's it. I see that as one of the great uses of the scans as well, right? Having that scan on file for stations that are out in the middle of nowhere, not having to send a crew out there to take some pictures or measurements. Yeah. Just pull up the scan and like you said, it's so much more accurate today, right?
Yeah, we did a substation for utility, and we did the low side of the substation, and we wanted to get all the measurements we needed so we could prefabricate the jumpers. And so, once we put the low side in, then you know where you're at in relation to the transformer and where you're trying to hook up. So, but what happened was a scan collected the high side part of the yard. And what happened was, we thought we wanted to do the high side. We want to at least do the prefabricated bus. So we put some structures in just to see, and just to put some bus in and everything. And the footing, the foundations for those high side structures were way off. It was not, they were not happy people when they found that out. But had they not found it out, they would have had these structures up in the air, and they would, try to fit the bus in and all this kind of stuff. So, it's amazing during the construction process how things go awry sometimes. And it's better to have that scan. That's a lot of people were doing scans during the process of scanning. Scanning for people who put in the slab, and we scan the framing so we know where the plumbing is, and if the framing is off or it's out of level or whatever before that slab is poured. That in itself is huge. Companies, they tell me, man, it's a lot of things could have gone wrong. We could have spent a lot of money having to redo things. So anything you want to do, I don't care if you want to build a fence in your backyard, knowing where things are is very important. So having that ability to scan, and now we can do it with iPhones to some good quality, actually. So maybe not as good a detail, and maybe quarter inch tolerance, but you can get it close, so it's helpful.
One, and circling back, it's a complete perfect example of why you want to use 3D, right? I mean, it really is that justification for doing the assembly and the model in the first place. I remember doing a couple of projects 16 years ago, and we're given a bunch of 2D, we're given the two-dimensional drawing package, right? All the blueprints for the station, and they wanted to model it in 3D. Yeah, you get like a quarter of the way into it and nothing fits together in the model. Yeah. And so you realize the drawings were never updated. So you go back, and they'd have to send someone out, take some measurements and take pictures back then, And it's just, it's so much work just to try to get an accurate representation. If you can overlay it on the point cloud, job done.
Absolutely.
All right, Michael. So I want to ask you, because you've got such a long history with the SDSIC. So I really wanted to touch base on, going back to your first involvement. I can't ever remember you not being involved in the SDSIC.
Yeah, because it actually happened in 2015. I did that AU presentation on taking the leap from 2D to 3D. and I forgot who it was. I think it was Alan Saunders, but I don't remember. Somebody came to me after that class and suggested they were having the SDSIC meeting at AU that year. And he said, I would like for you to sit in on that meeting. And I said, okay. So
Awesome.
it was Alan. But anyway, I said, okay. He says, you're not a utility and all this kind of stuff. And I said, yeah, I understand. It'd be great to sit in because we use Inventor, right? So
right.
we do substation. We're on the manufacturing end at the time, and so I sat in, and it was really interesting to sit in, and I think at the time it was John Thomas who was the president, and Terry Hummel, and a number of other people, and I think it. Trying to remember all the names. I guess I'm getting old, but from Duke Energy. So it was great, actually. And I sat in on that. And it was at that point in time that I think there was, as you mentioned earlier, there was starting to be, people were thinking about, okay, how are we going to work with our vendors?
Yes.
Material suppliers, engineering firms, contractors, people like that. So I think they started thinking about it. And I think that's really how it started. And, I would just come to the meetings. I always told Joey, I thought it was a good thing to be involved in it. So I think sometimes Chris would go, and over the years, we felt like it was good to have a representative from the people who were, basically their suppliers. And I think, and that was when Empirical, I think, started getting involved, and then the other, Burns and McDonald and people like that, and then you had Cefcor. Cefcor was a great help because, we were using their fittings to do prefabricated bus, and we needed those models.
Right.
And Elizabeth and all the people there were great in getting us those models. I mean, that was one of the greatest things in the world when they were involved. And then now you have, people like Southern States and other vendors that are now realizing how important it is to have the exact content. I mean, down to you don't have to have every little detail, all the clearances for equipment in a substation. And so having them as accurate as possible is very important, especially how they operate. So it's been good to have that. And that's how I got involved. And I've just been interested in it the whole time. And when I retired, from Distran, I felt like I wanted to still be involved in the effort. So that's been my, so I've tried to make it to as many of them as I could. Of course, we had the pandemic, and unfortunately I can't be there this year, but I definitely would like to in the future. I think it's a great community, and it really helps having everybody meeting everybody and learning how people do things and improving how they do them, and just getting support, because it's a difficult subject. It's one that among utilities, it's a hard thing. It's a hard bite off, So, and even really among suppliers, it's not that easy to do. So I think the more support you have, the better off you are.
Yeah, and I think we should give Elizabeth and Erica at Cefcor a little shout out. Let them, you can find all their models, right? You go to utilitycontent.com. They've got, I don't know, I think they're up to like 6,000 parts now, I think they have up there.
Yeah, I know. Awesome. I think about it. I think about all the content now. We have so much content that a lot of it, we don't need anymore, but still, I mean, the amount, and that's really what you need. I mean, the Revit community, everybody, it's all about content when you're doing 3D modeling. So you need to have that content, all the manufacturers, that's when I started doing the AEC end of this, it was amazing. I could go get a toilet. Vanity. I could get a towel dispenser if I need to put a bathroom together. And in 5 minutes, I had that bathroom together. It's amazing. And the funny thing about it is that most of the people who make things made them with digital tools like Inventor or SolidWorks or Creo, PTC, or Siemens NX. I mean, that's what they used for their modeling and design. And
Yeah.
prototyping and everything, and they have models. It's whether or not they want to give them to you and what they look like when you get them and if they work for you. So the content is there. It's just a matter of getting it. So
yeah, I'm glad you brought that up. That's a big shout out to all the vendors. It's been a big push, and it's a credit to the SDSIC because as a community voice to the vendors, we get a lot more action and reaction from the vendors than we do when each utility is calling them separately and asking for models or even part of their procurement, right? It's the vendors tell me, listen, each utility wants a separate way. They want a different level of detail or asking for different things to be put in the model. It's like, we just can't manage it all. Right? But if we can get 100 SDSIC utility companies to say, here's the level of detail we want from the vendor, here's the orientation, all that kind of good stuff we need in models, it's a lot easier for everybody, for sure. Yes. So thank you for bringing that up. That's a great point for the SDSIC.
Yeah, and really on the part making side of this, it is a different aspect of Inventor. It's totally different. People don't realize this when they're getting into using the technology, because most people are using it, as I mentioned before, for assembly. But making parts is a lot more difficult than it looks, and making them accurately. And there's tons of ways to approach a part. Some of the parts we've been making for some companies, small parts, we scan the parts and then we bring them in and we try to recreate them. I'm telling you, it's not an easy thing to do, because they want STL files so that they can send it to a foundry and have it cast. And it's got angles and curves, and it's like a car, right? So it's not an easy thing to accomplish. And kudos to people who build parts, because that is one of the most difficult parts about building a substation, is getting your parts together, making sure they're right, and that type of thing. So a big piece of this for people who are getting into this, you need to have parts makers. And not that that's all they do, but they need to learn how to do everything in an Inventor, but the parts makers are the ones that you need to really keep things going.
Good advice. Yeah, no, and it's funny because it's the AEC industry. It's always our point of reference for content, right? It's like, if you look at Revit and all the content libraries, as you said, you can get a toilet, a vanity, whatever. They've been doing it for forever, but they do have a very, consistent way of working, right? It's the BIM level of details and things. They nailed that stuff 25 years ago. And that's a big push for, the physical committee, even the electrical committee, right? The P&C side, everybody wants a different symbol. You have to you end up with a whole symbol library for each utility. It's pretty painful for anybody trying to deliver, right? So that's great reference to the AEC.
Yeah, and that's when you set up your templates in Inventor. So you have a template for AEP, or you have a template for whoever. That's the best way to do that, right? You have a group of parts for that customer. You have all of their standards. And that takes some time to set up, but it really is beneficial if you're going to do work for them. So from a supplier standpoint, that's the best way to set up things.
That's awesome. I was going to ask you at the end for advice to the folks out there just getting started with the SDSIC. I think you just nailed it. But you got any recommendations for, maybe, I'm thinking like some new folks, like I saw in Kansas City. A lot of folks coming in for the first time. They're looking at 6 different committees now. How would you recommend, or if they were going for the first time, they're showing up in Nashville, what would you recommend?
Well, I've always been on the physical side of the substation. Not, we deal with the electrical side because we have to know things like how to space things and corona issues, but the electrical side is the part that really needs the work. And I think I'm hoping to see the electromechanical aspect of Inventor really take off in the future. That, it's there, it's built into the system. People use it to build the cars with. BMW uses it. So it's there. We just haven't really crossed that bridge, unfortunately, yet. But starting out, you pick the low-hanging fruit. And it's just like we did at Distran early on. What was our biggest problem? Well, we had steel models that did not represent on paper what they really looked like when they were built, because a 40-foot column cannot be put on a 24 by 36 sheet and make it look correct. So, you have to, the things that are the biggest pain points in your business are the ones you're trying to solve, but you got to bite it off a little bit at a time and try to determine what's the best path. So the planning, for me anyway, and for our companies, has been very, very important. Where are we going to go? How are we going to tackle this, and so on. And just preparation, I guess, would be the biggest thing. And then, don't be afraid of the technology. You definitely need to embrace it. It's getting better, and Autodesk has now made interoperability anyway a lot easier between their different offerings. Now, when you come to other manufacturers or other suppliers like SolidWorks, Dassault Systems, or Pro-E, not Pro-E, but Creo, PTC Creo, they're trying to do the same thing. So all the software vendors realize that there needs to be interoperability between the software offerings. It's just a matter of deciding which one you want to use and which road to take. A lot of companies already have some type of software. You may have MicroStation or AutoCAD. That's one of those things that you have to try to decide how you're going to go. And it's not an easy decision sometimes, but now, again, you can open up a DGN file in AutoCAD.
Right.
It's not as difficult as it used to be. And I think the beauty of things is that the suppliers, especially software suppliers, have realized that.
Man, that's so true. I'm actually a Pro-E guy from back in the late 90s. I used to program and build add-ons for Pro Engineer, all the PTC tools. Back then, it didn't talk to anybody. if you had a Pro, you had to go STEP or ASUS, and even then, I think you had to buy a module to export to ASUS.
Exactly.
Yeah. Good point. No, that's great. And somebody had mentioned this on the podcast that the kind of the interoperability between equipment. It's also the same at the consortium, really, to have folks from the physical group go over and attend one of the electrical committees, or go and attend, technology or civil, and kind of try to mix it up a little bit. And you might realize you might be able to help different departments when you get back to work, because I've seen that. And somebody mentioned it on the podcast. Maybe it was Mark Nelson. He said, it's nice to see a physical guy sitting in the electrical room go, oh, that's what you're doing. Oh, right. I can give you that in the file.
Exactly.
Yeah.
And that is it's the big picture thing, right?
Yeah, that's great advice, man.
You need to, the tools we have are awesome, right? We use a very small part of what they really can do.
Right.
The biggest thing that I realize, we do finite element analysis with it with some parts and things for customers.
Nice.
And it's not a tool I've ever really used, but it's amazing what you can do with it. So all the little things, you can build machines with Inventor, you can do simulations, animations, which is one of the things I love to do.
Yeah.
Animations when I was at Distran, and they were just, we would do it just to try to sell a concept to a customer. And it's amazing how just being able to see how things go together makes a huge difference for somebody as far as making a decision. So Inventor Studio, man, is the way to go.
Yeah,
that's right. Down and dirty animation. Yep. So
that's awesome.
Yeah, I try to use a frame generator. I mean, when we frame up a house or a boathouse or whatever, we have a 3D sketch, and we put 2x6s and 2x4s. They're automatically trimmed, and then they come out, and we send them. We create a 3D view of it and a link, and send it to the field, and they cut it right there. We had people that didn't know how to cut a compound angle on a rafter, and 3D printed the sleeve that they needed to go around the rafters, so they could just run a pencil around it and cut it.
Oh, that's awesome.
I mean, and they look at us like, what the heck? So
what black magic is this?
That's the kind of people who are out there today trying to build things. They really don't know. A lot of them are young. they don't understand what they're doing. And so it's a challenge for sure in getting things built. So a lot of technology helps to do that. And that was, knowing electrical, knowing civil foundation work, making rebar cages, all that kind of stuff, understanding things like helical piles. I just sat in on a Burns and Mac. I always thought helical piles was really to our industry. They were introduced to us at Distran back in like 2010 or 2011. They were using them in refineries. All you have to do is look at refinery. Look at the oil and gas business from a refinery standpoint. It's amazing what they've done. It's all prefabricated. It's all modules now. Very rarely do things on site. It's all assembly on site. So modular, I don't want to toot my modular horn, but it is the answer to a lot of problems. And I think the people that are doing it have shown that, and it continues to be the wave of the future. There's not enough people, and there's the capabilities on site are getting worse every year. So the more just plug and play, the better off you're going to be.
Yeah, there you go. Well, and you heard it from the man himself. I mean, all of this technology is a lot easier than selling equipment to the oil rig guys. That's got to be tough. that sounds like one of the tougher jobs I've heard so far.
Yeah, it was. And, back then we didn't have all this, right?
Yeah, so that's right.
The engineering offices were staffed with hundreds of people, with pencils in their hand.
Yeah.
And
smoking cigarettes and
smoking cigarettes. Oh, Lord, it was something.
That's great, Mike. So let's talk about, things you see coming in the future. I know you and I had talked early on. We tried a little project with AR. I think we're both big believers in trying to get rid of some of those dimensional drawings. And, to me, the whole metaverse and everything, to me, it's all about AR. But I know you're a big proponent.
Yeah. Yeah. And over the past, I guess, 5 or 6 years, maybe it's longer than that, maybe 7. One of the things that Inventor offers us is the ability to export or really share. It's a collaboration tool for a viewer, similar to the Forge viewer some people may have used. It's basically an Inventor viewer.
Right.
And we use model-based definition, which is really just 3D annotations that are available in Inventor. Most people may not know about it, but 3D annotations to dimension and to tag. And like if you want to take I don't know, you could take a column or something like that, and you want to dimension it, do whole dimensions, all that kind of stuff. Well, what you do in the drawing environment, you can do now just in the model environment. And what we tried it for a while to see if it would work. It ended up working really well. So instead of creating drawings, we send out these links. It creates a link when you export the view. And it's essentially just a link that anybody can pull up on their phone or computer or whatever they want. And we've been working with it in the shop where we have big computer screens, and we're able to pull up an assembly or whatever. We have the bill of material there. We can zoom in on a particular part and find out what size bolt that is, what size wire. So it's a great information tool and easy to do without having to create a lot of detailed drawings and details from it. So you take the whole model or a piece of it or whatever you want, and it's this tool. So what it lends itself to is the ability to use augmented reality or mixed reality to do the same thing. The only thing is, instead of putting it up on your computer screen in the shop or a tablet that you're carrying, you have it in basically a viewer in goggles. And the Microsoft HoloLens is the one that comes to mind. There's other offerings out that have been people have been working on, but this is really where it's going initially. So instead of you having a drawing with you, you're going to have all this information really at your fingertip and in a viewer that's easy, where you can, your hands free, you can use both hands, and you can do your work a lot quicker and more productive. So what I see coming, we do it with VR somewhat now. We can walk through a substation. We can see where things are. So stakeholders and people who are, constructing the station can see what to expect in advance. So that's where 3D modeling or the BIM model really comes into a huge benefit for a lot of people. And that's, for me, the way it's going. We did try the HoloLens, and the only problem we had with it was that we didn't have as much we didn't have any really peripheral vision.
Right.
Bit of a problem because we really had to have a spotter. So you need two people. The person had to spot for the one using the HoloLens. It worked great for them, but it was just having that extra person and the safety issue. So I think, it's going to change. Hopefully those glasses are going to get easier to use. And that's really the thing that's really holding us back, honestly, in a lot of industries. It's not just ours, but a lot of manufacturing industries are seeing this as the where we're going to go in the future. So we're going to pretty much go to a paperless approach, even though you can still take these model-based views and you can put them on paper. You can put the model on paper and just if you just scroll in your maybe I'll do a YouTube video or something on it, but you can just scroll down and you can find the 3D annotations in there and click on it, and they all show up on your screen.
Yeah.
Or show up on the page. So you didn't really have to dimension it twice. You dimension it once and then you decide, I need a PDF or I need a paper version of this. Well, you can do it quite easily.
That'd be great. Yeah, you should do a YouTube. I think the physical group has a YouTube channel going. You could probably put it on there.
Yes, I have seen it. Yeah, Josh has done a really good job. I have to commend him.
Yeah, he does a great job.
He's just amazing in terms of the things he knows and the things he thinks about and all the innovations, that he's put together. And there's a lot of us. I mean, Chris Ducote, I mentioned him. Kelby, all these people who are great. There's a lot of great Distran people out there, I have to say.
Yeah.
Not to toot my horn or anything, but we actually had a good group of people, and they still do, unfortunately. Power took a lot of them, but, and SBS took the others, but they still do. I mean, it's a virtual, incubator.
Yeah.
Forward substation thinking, if you will.
And I think Steve Kaufman puts a lot of stuff out there on the YouTube channel for them and everything. But, you and I had tried, I kind of compared the mixed reality stuff, and you had provided me with one of the models with all the model-based dimensions and everything. And I ran it through the HoloLens, and much like you said, right. It's very, very narrow view. It was very hard to see in the daylight as well. Right. Yes. It kind of gets so washed out. You couldn't see it, but we talked about it before. I kind of compare it to where CAD was, as we discussed back in the day. You couldn't take a Pro E model and move it to this or that. It's kind of going away a lot quicker on the mixed reality side. I find it evolving so fast because part of the problem was moving it from Inventor to Unity to Unreal Engine, all that kind of stuff that we had. Each one of those loses something in the file types that they don't share, but it seems to be changing quick, right?
That is the key to it, is moving that model into that environment for sure. We have, I'm not a C# double sharp Q programmer. So I'm a boomer, right? So it's even worse.
That's right. I'm a coder by nature. I can't get it to work, so it's fine. It's not you.
But yes, that is the key. These kids need to get on it and figure out that.
Yeah, that's right.
How that's going to work, because it is a big gap right now, but it is the future for sure. Absolutely, no doubt about it.
Yeah, no, I love it. And if all the folks listening they don't know what we're talking about, I would say go on Google Earth now and you do those pins and you walk around from a point of view of the Google Earth side. You walk down the street. When you see all those little icons in front of stores and everything, that's a little image of what's coming. And when the glasses are smaller and that we could all wear them like a mobile device, it's coming. That Charlie Fink is the Forbes kind of futurist. He had a great saying. He said, sooner or later, the entire world will be painted with data.
Yeah. Well, you know what the problem is? It's Apple. Because we have been waiting for them, because when they put it out, it's probably going to be the answer, right?
Right. Yeah.
So if Apple comes out with a solution, then I think we're close. It might be expensive at first, but there's tons of productivity benefits. And of course, like you said, you got to be able to see it out when the sun's shining. And that's a little tougher to do, but that's the goal. I mean, right now we're sending the geometry of the job site to the excavator. And, CAT now has bolt-on GPS systems that drive these tractors, and they are, we're farming with it. As long as you know where you're at in 3D space, we can tell a machine where it's got to go. So that's, that and having the ability to see the model or your design or whatever in 3D, not built yet, is also, those two are kind of going hand in hand, and then bringing in the 3D scan part of it, because that's how we're going to really build models, is with those point clouds. We're building an actual model instead of one that's the way we designed it. So if your slab is out of plumb by half an inch over 20 feet, and you go to 3D print your concrete wall on that slab, it's going to know that it's going to have to give you a little bit more. It has to be level when it gets done printing. So all those, it's all connected. It's all interconnected now, and it's scary from my perspective, because I've seen a lot of things in my life, but the people who are playing video games and all that, they kind of been living it just in a virtual reality instead of an augmented one. So, but it's coming.
Yeah. There you go, man. Well, great.
We didn't even mention ChatGPT.
No, thank God. For one conversation. Can't go anywhere on LinkedIn and not see it now.
Or AI.
Yeah.
I have to put AI in my list of things I do now, or people aren't going to want to talk.
It's kind of like when the whole .com came along, right? We had to be a .com. Well, hey, I really appreciate it, Michael. And you're really active in the community. We all love when you're involved and you're posting things, and I'd love to see some YouTube videos, man. So keep up the great work.
I think I'll do that. I have some time. I have a little more time this year, so I might do some of that. I think it'd be helpful to some people.
Yeah, I think it would too, man. I think we'd all appreciate it. I think there's a lot of folks out there that could benefit from that. So please don't retire again.
Okay. Well, the problem in the past is you have, companies, are competitive, so they really don't want to give out some of their secrets and things like that. And I can understand that, but you also at the same time have to progress. So it's a tight, a line you have to walk a little bit, but it's just really finding the little screws to turn. I mean, honestly, that's all it is wow, I opened this up, and I mean, we used to talk about that, okay, what's the inventor tip of the week that we discovered?
Right.
Know about, right? I mean, every company that probably goes on among the users, especially, hey, look what I found. Well, it's like I used to say, inventor is basically a round room with 20 doors. And every time you open a door, you're opening it to another round room with another. And then you open that, and so that's inventor. So know which door to open and know where you're at when you're in that room, related to all the other rooms and all the other doors.
Beautiful. Yeah, great advice, Michael. Hey, thanks for joining me today, man. That was awesome.
Well, thanks for having me.
Thank you for listening to the Power Up Podcast today. If you enjoyed this conversation and you're not yet a member of the SDSIC, join for free at sdsconsortium.com. Be part of the community and all these great conversations. And maybe you'll be the next guest on the Power Up Podcast.